This is our third video on A2 integration, and so we're now going to be evaluating definite integrals. So those first two videos we were just showing various examples of integrating as a backwards process of differentiation. Here we have definite integrals then to evaluate, so let's take a wee look at this one. So again, it's a fairly complicated looking one, minus cosec a half x cot a half x. However, hopefully we remember, hopefully we can look from our formula book, that if you differentiate cosec x, you do indeed get minus cosec x cot x. So we can manipulate it in that sense there. So we can write this as, in fact, this goes straight into integrating. Hopefully you can see, so the half x there, that means we're going to have a cosec half x somewhere, and it ends up being minus 2 cosec a half x, and we're doing that in between pi over 2 and pi over 3. So where did I get that from? I know again, if I differentiate cosec x, I get cosec x cot x. So if I differentiate cosec a half x, I would get a half cosec a half x cot a half x. So I need to take the minus 2 out to make that work. Subbing our values in then, it's going to be minus 2 cosec pi over 4, because I put the pi over 2 in here, times it by the half. Take away minus 2 cosec pi over 6. Cosec is of course 1 over sine, so it'll be minus 2 over sine pi over 4. And then plus, I'm doing the minus there, 2 over sine pi over 6. Sine pi over 4 is 1 over root 2, so I get minus 2 all over 1 over root 2. Sine pi over 6 is the same as sine 30. Obviously it's going to be a half into 2 goes 4 times, so we're going to have a 4, and multiplying top and bottom here by root 2, and we'd end up with minus 2 root 2 plus 4. Second example then, let's take a wee look. Bring it down so you can see it. So it is now the integral of e to the 4x minus 3 in between minus 1 and 3. So again, we need to consider a backwards differentiation, and it would make that work. If I differentiate e to the 4x plus 3, I get 4 e to the 4x plus 3. So if I integrate this, hopefully you can see, then we're going to end up with a quarter. So integrating this is a quarter e to the 4x minus 3, and that's in between 3 and minus 1. Sub in 3, I get 12, take away 3, which is 9, so it's a quarter e to the 9, take away a quarter e to the minus 7, and not really much in terms of tidying up there. I'm going to take out a quarter, I suppose, if you wish, but it's going to be a quarter e to the 9, take away e to the minus 7.